Okay, so we're going to do putting it all together here. Now that we've done some pieces, we're now going to put it all together and actually sketch a curve. And so what I want you to do in these first couple boxes is I want you to think, if you knew the first derivative was positive and the second derivative was positive, what would f look like? So with this first one, hopefully you think, well, that has to be increasing because the first derivative being positive, we do have an increasing function. And then the second derivative meaning positive means that's going to be a concave up. So increasing and concave up looks like this-ish. So that's what I want you to do for the rest of those is see if you can draw a little piece of a curve that would match those things. So stop the video, try, and then come back. This one would be decreasing and concave up. So that would be kind of that side, the left side of the smile. What if the first derivative is 0 and the second derivative is negative? Well, that's the second derivative test, right? What's going to happen if you have a first derivative being 0 and the second derivative is negative? That would be something like this. At this point right here, this specific point, not that whole thing, okay, but at this point, the first derivative is 0 and the second derivative is negative, so it would be concave down, and I would have a maximum. All right. Increasing and concave down, increasing and concave down looks like this. First derivative is 0 and then concave up. So what am I going to have there? I would have a minimum. So again, I'm not talking about that whole piece. I'm talking specifically about that one dot on that piece. And of course, negative, negative. Let's see, that would be a decreasing concave down piece would look like that. So here's what you're going to have. You have gotten all of the information from f prime and f double prime. So I just kind of wrote out some maxes and mins, a point of inflection, and the second derivative, first derivative sign analysis, and then you have to draw the picture. Now there's many, 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 many ways to do this, but I will tell you what I do. Okay, the first thing I do is I plot any points, because if I know that 1, 7 is on the graph, well then, you know, kind of helpful to plot it. So I plot that. I have a local minimum at 3, negative 5. I have a point of inflection at 2, 2. So I know I have those 3 dots. Then, what's easiest for me is I kind of dot in the increasing and decreasing. I know I'm going to increase, so F is going to increase, then decrease, then increase. And I literally kind of do this on my graph. And I dot it in real lightly. I'm like, okay, I'm going to increase to 1, which makes sense because I have a maximum. I'm going to decrease to 3, and then I'm going to increase again. And I do it with those straight lines. Then I put the concavity in it. So it makes sense that I'm going to have a concave down piece until 2, and then concave up until after 2. So you can kind of see I just put the concavity in there. So I make it very obvious. I'm like, okay, I need to have a concave down piece. I have a point of inflection, so it's then going to go to concave up, and so this is the point where it changes. Now, I don't care if you erase that dotted piece. That doesn't bother me if you do it real light, but if you dot that in, that's fine. If it bothers you and you want to erase that dotted piece because you just like it better, well, then you do that, okay? It's kind of hard for me to do that on this iPad, but that's what my graph would look like. So why don't you try number 3? Okay, stop the video and try. All right, let's plot our points. 3, 0. Let's That's going to be a point of inflection, 7, 1. 4, this one's kind of real scrunched in here, isn't it? 4, negative 2, and then a minimum of 5, negative 5. Okay, got a lot of dots in there. Okay, so what is F doing? Well, F is going to be decreasing to 5 and then increasing afterwards. So I'm just going to, okay, it's going to just, I just decrease to 5 and then increase there. Then I'm going to put my concavity in there. And you can go piece by piece up until 3, concave up. So notice what I'm doing. I've got a decreasing piece that is concave up. So kind of like I did up in this chart. I have a decreasing piece that is concave up, so it's going to look like that. So I'm just kind of putting it together. I know that I've got a point of inflection at 3, 0. So I'm going to go concave up to concave down, because this is concave down between 3 and 4. Then I'm going to go concave up again to here. And guys, you need to make this super, super, super obvious to me, okay? I've got to be able to tell. So that looks concave up, then it's concave down, then it goes concave up again, and then at 7, it goes concave down. So I'm going to go concave up to concave down, and it's going to do something like that. So I know it's kind of hard to do that, but you just need to make it very obvious for your grader. Is that concave up or is that concave down? It certainly can't look like a straight line. You know, it can't look like this because that doesn't have any concavity. So you're just kind of fitting it all together and putting it all together. Now let's look at number 4. And man, that's a great question. Oh, this is so AP, people. So here we go. What do we got? Kind of crooked there. Oh no. Right. Okay. So you're given a graph. Notice this is F prime. I'm going to write that really big because I don't want to forget it. And it's talking about, let me read through my given, because when they have words, you need to read through that. The figure shows the graph of F prime. The graph of F prime has a horizontal tangent at -3, 2, and 5. So -3, 2, and 5. So I'm just going to put those numbers on my graph just so I don't have to keep counting. Okay? And a vertical tangent at x equals 3. So right here, I have a vertical tangent of 3. Okay. And I can assume, again, that these graphs go on forever if they don't stop. So when I write my answers, I'm going to do that. Okay. So let's see what's going on. Letter A, I'm going to label everything neat. Find the intervals of increase or decrease. I like to write my justification first because then it tells me where to look. I'm going to say you're asking, remember you're answering for f of x. F is increasing when f prime what? Is positive. Therefore, now let me write my answer. Well, if I just said, look where f prime is positive, where does f prime have positive y values? Well, you're going to say here, so -infinity to negative. You know what? I'm a silly goose. I just said it goes on forever. It said it was stopped at 7. They didn't put the dots, but they said it, so I need to read more carefully. Good point to make. Silly goose. So let's do that again. So where is f prime positive? That's going to be from -7 to -5. Where else? Right here. So where's that? That's from -1. Now what do I do at 5? Do I have to break it at 5? Do I say -1 to 5 and 5 to 7? Or do I put it together? Well, if the derivative is defined everywhere, don't you know, in order to have a derivative, the function has to exist. So I know the function exists at 5, so it's kind of like that. Remember, if I want to combine, I just have to ask, is the function defined? And it would be, so I'm going to go -1 to 7. Decreasing, f is decreasing when f prime is negative. So where is f prime negative? Where does it have negative y values? Well, that's just the part that's below the x-axis. So that would be -5 to -1. So that's part A. Part B. Find the relative max and mins. F has a relative max. Do say the word relative or local. Okay, I'll repeat the same word that's in the question. F has a relative max when f prime changes from positive to negative. Therefore, at x equals, where does it have it? Well, when f prime changes positive to negative, that's right here. I go from positive values to negative values. So f has a relative max at -5. Notice I can't find the y value because, I don't have f. So I can't plug it into anything. So you're only doing that. F has a relative min. When f prime changes negative to positive. So where is that? Well, that's at x equals -1. Perfect. Part C, intervals of concavity. Now, this is very, very important. You always want to justify, and you might want to write this in your notes. When it says justify, you must justify with the derivative given. So here's what I mean by that. Obviously, for max and mins, you justify with f prime. You were given f prime, so you probably didn't think about it. But in part C, when it says the intervals of concavity, you're going to say f is concave up when you can't say when f double prime is positive because you're not given the graph of f double prime. So you're given the graph of f prime. So you have to think about, okay, well, what would have to be true about f prime for f double prime to be positive? Well, if f double prime needs to be positive, then f prime would be, f is concave up when f prime is increasing. So you have to look at this graph and say, where is f prime, which is the graph you have, increasing? Meaning when you draw that graph, when is your hand going up? So that would be at this piece here, -3 to 2, and then 5 to 7. F is concave down when f prime is decreasing. Okay, so where it's decreasing, and this is a little bit confusing, is when f prime is decreasing, so that is going to be from -7 to -3, and then 2 to 5. Now, I know you're like, well, do I have to break it at that 3? And you don't, because f is decreasing. The derivative, this second derivative doesn't exist there, but that doesn't affect. F prime exists because you have a dot, and of course if f prime exists, then f is going to exist. So you're able to write those decreasing pieces. Okay, so part D says the x-coordinates of the points of inflection. So we know that F has a POI when F prime is doing what? When F prime changes from increasing to decreasing, or vice versa. Because we know that the second derivative has to change sign, but we're given the first derivative, so we have to justify that way. So when F prime changes increasing to decreasing, or vice versa. So where is that? That's going to be, so I'm decreasing to -3, and then I increase, so at -3, I go to increasing, so 2, and then 5. And those are going to be my POIs on F. And then the last one is to sketch a graph of the function. And so what you have to realize with the graph of the function is that you don't have any y values. And so when I'm drawing this, the y values are irrelevant. So don't think of that while I'm doing it. So let me draw a little coordinate system here. And I'm going to put kind of my important points that I have, that I've talked about in the previous answers. I don't know why I need 3 really. Don't know why I put him. I'll erase that guy. Don't really need 3, I don't think. And then I need 5 and 7. Okay, so like I said, what I like to do is I know where I have some maxes and some mins. I don't have any y values, so I'm just going to kind of put them up there. So I'm going to put a max way up here because I know I have a maximum at -5. I have a minimum at -1, so I'm going to put that here. So I know that's going to be my low. I also know I have some POIs, so I'll probably, if I'm going to connect, I might as well put those in between there. And I've got a POI at 2, and so I'm not really sure where that's going to be, but I know that's a minimum, so it's going to be somewhere up here. And I know I have a POI at 5 as well, but I'm not sure if I'm going up or down. So let me do this. Let's talk about where F is increasing and decreasing. I know F increases from -7 to 5, and then it decreases here, and then it increases all the way through. So I know it's going to take that basic shape, and so then let me put in the concavity. I know that F is concave up. Let's see, from -7 to -3, I am concave down. So my graph is I'll put just a dot here. I'll put a concave down piece. Then I go to concave up. So it shifts, and I will go concave up here at 2. I can adjust my points if I need to. And then from 2 to 5, it is going to be concave down. So I'm going to just kind of go like that. And then I'm going to go concave up, and I'm going to go like that. So I have some concavity changes there, which makes sense that at 5 my derivative should be kind of flattening out, which it looks like it does. And so there's my graph of F. Got a little sketch of it. Again, the y values are irrelevant, so don't look at that. Just look at what the kind of the shape of the graph, increasing, decreasing, concavity, that sort of thing. All right, peace out.